Okay, we've moved on to 7.3, exercise 5. In this case, you're graphing a system of linear inequalities. To graph the system of linear inequalities, 2 steps. First step, configure to slope-intercept, which you know equals y equals mx plus b. Once you've got it in that format, I know what is equals here, but you'll just leave the greater than or less than or greater than equals to or whatever the inequality symbol is in there. We'll reconfigure into this format. Then secondly, we draw the line, and the line is either going to be solid or dashed depending on whether or not it's a greater than or equal to, a greater than less than is a dashed line. Less than or equal to, greater than or equal to is a solid line. Okay, because we remember that the shaded area includes the solid line when you've got a greater than equal to, which that's a greater than equal to or less than equal to. And the dashed line means that the line itself is not included in the solution set where you have a less than or greater than symbol. So once you've drawn the line, then you choose what to shade. And it's all a matter of y. Why, you ask? Is y greater than the other stuff? Then it's the upper half plane. If y is less than the other stuff, it's the lower half plane. And we remember that the half plane can be upper or lower even if the line is like a super steep slope like that. Still you have an upper and a lower. So let's take a look at this one here, 7.3 exercise 5 on page 323. We'll look at B. And B says x plus 2y is greater than 4 and 3x minus 2y is less than or equal to 6. Now treating these as if they are equations and moving stuff around is fine. You don't have to worry about the signs as long as you don't multiply by -1. If you start multiplying by negative numbers, these things get messed around. They actually have to change direction. So stay away from that. Don't multiply anything by a negative number. So the system is represented by x plus 2y greater than 4. Remember, we're going to try to get y by itself. And the other is 3x minus 2y is less than or equal to 6. Now already I know that this one is going to have a dashed line and this one is going to have a solid line. I'm going to color code these so that when we draw the line, the color of the line tells us which which inequality we're talking about. So in this one here, let's get the x over to the other side. So 2y is greater than negative x plus 4. I've just subtracted x from both sides there. And divide both sides by 2. Y is greater than negative 1/2 x plus 2. So this is the equation that this is the inequality that I can use to draw the line. A slope of negative 1/2, a y-intercept of 2. And this one I'm going to change into my slope-intercept format as well. Let's add 2y to both sides because I just want to keep the y's. I want to get the y's by themselves, but I don't want to multiply by any negative numbers. So I'm going to add 2y to both sides, and I have 3x is less than or equal to 6 plus 2y. Then I subtract 6 from both sides. I get 3x minus 6 is less than or equal to 2y. And then I divide both sides by 2, and I get 3 over 2x minus 3 is less than or equal to y. So this is still my slope, and this is my y-intercept still. And the reason I did it so funny like this is I want to stay away from multiplying anything by negative numbers. Had I simply moved the 3x over here, I'd end up with negative 2y. I'd be tempted to divide both sides by negative 2, and that would have required me to shift the sign around, and I don't even want to go there. Okay? I'm never going to multiply by a negative number if I don't have to. So here's my two lines that I'm going to draw. Let's start with this one here. The y-intercept is at negative 3. and the slope is 3 over 2. So it rises by 3 and it runs by 2. Rise by 3, run by 2. Rise by, wait a minute, 1, 2, 3, and over by 2. So we get the general idea. Let's remember it's a solid line because it includes the line, so I'll just use my iPad cover here as my handy dandy ruler. And there's my first line, there's the pink line. The blue line here, I know it's going to be a dashed line. It's going to be a dashed line because it's a greater than sign, so the solution doesn't include the line. Plus 2 is the y-intercept, and the slope is negative 1 over 2. So rise by negative 1 over by 2. Rise by negative 1 over by 2. Rise by negative 1 over by 2. So that's given me enough so I can draw that out. And it's going to be a dashed line, slope of negative 1/2. Less than perfect. There we go. So now I've got the lines on the page. It's a matter of deciding what to shade. And I'm looking for a solution set for both of these. So I have 4 potential areas. There's this area, there's this area, there's this area, and there's this area. I'll just refer to them as quadrants because there's 4 of them. And one of those 4 quadrants is the solution set common to both of these. So in this case here, y is greater than that stuff. So in my pink equation, y is greater than that stuff, so it's the upper half. So it's going to be up here somewhere. So I've got this one or this one to choose from. Those are my only 2 quadrants left, because it has to be the upper half plane with respect to the pink line. The blue one, y is greater than that stuff. So it's going to be the upper half plane, upper from the blue line. So it must be this quadrant here. So the quadrant that I'm going to shade then is this here. And that is my solution set. It includes this line, but it doesn't include this line itself, and anything up here will be a solution set. If I pick this point right here, I could take its coordinates, I could plug it into either equation or either inequality, and it would be true.